In this video, we are going to look at chemical bonding and in particular stability of atoms. You just need to have some information on electronic configuration for you to get going. Whenever someone talks about stability of atoms, they will never forget talking about noble gases. This is because we know that these gases basically are kind of inert. They never want to participate in reactions unless when forced to. So most atoms also want to be kind of stable. When something is not, it's kind of stable because it's not trying to react with other elements. It wants to maintain form. So these noble gases kind of are like the role models of these other atoms that want to gain stability. So noble gases are well known for having a fully filled outermost energy level. That means the last energy level has the maximum number of electrons. So all noble gases will have 8 electrons, with exception of helium, which has only 2 electrons, just because the first energy level can have a maximum of 2 electrons. So whenever we have atoms combining to form molecules, there is a force that will always be developed that can keep these atoms together. And this force that links the atoms in a compound is called a chemical bond. However, it's not always necessarily that we shall have atoms. We can also have ions together to form a chemical bond, as we shall see later on. The sole purpose of any atom, whenever it's trying to form a bond with another atom, is to try and obtain a stable electron configuration, and with that we mean one that is always similar to the noble gas electronic configuration. When you look at the table below, we have helium. Helium has 2 electrons, and when you look at helium, it has 1 energy level. This is our first energy level, second, third, fourth, and so on. So helium has only 1 energy level, and it's the outermost, and in this case it has 2 electrons, and this is the maximum number of electrons that can be obtained in the first energy level. That's why helium is able to be stable. When we go to neon, neon has 10 electrons. However, it has 8 electrons in the last energy level. Argon also has 8, krypton, and the rest. So one thing you realize is that apart from helium, all the other noble gases have 8 electrons, which is the maximum number of electrons these energy levels can have. And this has been associated with these elements being stable. And as such, all other atoms, whenever they are trying to bond, they want to ensure that they have at least 8 or 2 electrons in their last energy level so that they become stable. So we can summarize what we have so far seen in a few lines. We have noted that atoms always combine to ensure that they achieve the inert gas electronic configuration so that they become more stable. And we had seen that it requires these atoms to have the maximum number of electrons in their outermost energy level. You can read about the octet rule. This talks about the need for an atom to have 8 electrons to be stable. However, for some atoms which have only 1 energy level, they just basically need 2 electrons to become stable. So what can an atom do to achieve an inert gas electronic configuration? There are actually 3 possible ways for that to happen. The first one is it can electrons so that it becomes stable, and in this case we'll lose those electrons to another atom. Let's take a scenario of sodium. Sodium has atomic number 11. That means the electronic configuration of sodium is 281. So sodium can lose the outermost electron, this one, to another atom, say chlorine. So it will lose one electron, and the new electronic configuration will be 2,8. And in this case, this will obey the octet rule that we had just seen. The second example could be for aluminium. Aluminium has atomic number 13, and that means electronic configuration is 283. So aluminium will need to lose 3 electrons so that the new electronic configuration becomes 2,8, maximum number of electrons in the last energy level. So in this case, sodium has lost this 1 electron, while aluminium will lose these 3 electrons. So this is an example to show that some atoms can lose 1 or 3, and an element which can lose 2 can be magnesium. Try it out and see how stable it will be. The second method is by gaining 1 or more electrons from another atom. The first one was losing 1 or more electrons, and the second one is gaining. So atoms with 6, 5, and 7 electrons in their outermost shell can always gain 2, 3, or 1 electron to attain stability. Let's take an example of chlorine. Atomic number of chlorine is 17, and that means electronic configuration of chlorine is 287. So for chlorine to become stable, it will actually have to gain 1 electron so that the new electronic configuration becomes 288. So it can't lose 7, it will gain 1 electron. And this is an example of an atom gaining 1 electron. And because it now has 8 electrons in the outermost energy level, this is identical or similar to the electronic configurations of noble gases. So atoms that have 5, 6, 7 electrons in the outermost energy level, like chlorine has 7, can gain 3, 2, or 1 respectively to attain stability. The third way is by sharing 1 or more electrons with another atom. So still, atoms with 4 to 7 electrons in the last energy level can do so by sharing electrons. Let's take an example of chlorine. We are sketching the outermost energy level of chlorine. Remember, electronic configuration of chlorine is 287. So we shall need 7 electrons. So we have 1, 2, 3, 4, 5, 6, 7. However, this chlorine will need to bond with another atom so that they can share 1 electron. So we shall sketch another atom of chlorine. It also has 7 electrons in the outermost energy level. 1, 2, 3, 4, 5, 6, 7. So you realize that the chlorine atom in red and in blue, they all share certain electrons. The 2 electrons in the center are the ones being shared by both electrons. This electron 1 and electron 2. So if we are to count the number of electrons of the red chlorine atom, we shall have 1, 2, 3, 4, 5, 6, 7, 8. And in the same way, the one in blue will also be having 8. So because the electrons being shared are for both atoms, so the atoms no longer have 7, but they have 8 electrons in the outermost energy level. So sharing of electrons is another way of obtaining stability. Thanks for watching. Hope you learned something new from this video. So our next video will be about formation of ions from atoms. So if you're new here and you haven't subscribed, consider doing so that you don't miss any of our new uploads.